At first in this video we're going to start with review, but then soon we'll see some mysterious behavior of Matlab, and then we'll talk about what the meaning is behind it. So imagine I wanted to make the vector 2 squared, 2 cubed, 2 to the 4th. How could I do that? Well, here's a way that doesn't work. If I do 2 to the vector, I get an error, and the key word here is that I was supposed to use element-wise operation, or what I also sometimes call component-wise operations. And if I put a period here before the caret symbol, before the power symbol, then this tells it do 2 squared, then 2 cubed, then 2 to the 4th, and put it into a vector. Okay, so there we go, 2 squared, 2 cubed, 2 to the 4th. So we haven't talked much about built-in constants to Matlab, but they exist. For example, if I type in pi, there's pi. Okay, if I want to see more decimal digits of pi, I can do format long, and now type in pi. Okay, but let's just go back to the regular one. I can also see e. Okay, I can't just type in e, that doesn't work. But if I type in exp of 1, the way you should think of that is as e to the first power. Okay, so 2.71828 ... Here's how it's approximated when it's printed to the screen. So based on what we did above with the element-wise power, I'm going to make a vector v equals pi element-wise power 1 to 8. And then I'm going to suppress it from getting printed to the screen by putting a semicolon after it. Okay, so there we go. So this is a length 8 vector that looks like pi, pi squared, pi cubed, all the way up to pi to the 8th. Now let me do something very similar. Let me do w equals pi. And now let me have -1, down by 1, -8. So what did I just do here? I made pi to the negative first, so that's like 1 over pi. Then it goes down by 1, so 1 over pi squared, all the way down to 1 over pi to the 8th. And what if I want to multiply these two vectors element-wise? Okay, then I have to put a period before the multiplication sign. And let me name this vector u. And again, I'm going to not print it to the screen by putting a semicolon after it. Okay, so what have I done? I've done pi to the first times 1 over pi, pi to the second times 1 over pi squared, pi to the cubed times 1 over pi cubed. And now remember how logical vectors work in Matlab. Okay, so what do I get if I type in vector equals 1? Okay, what's it saying? It's going through each of the 8 entries of u. Okay, if I want to see how long u is, I can do length of u, length 8. If I want to see what its dimensions are, okay, this is telling me that it's 1 row and 8 columns. So if I do u equals 1, this is asking true, false. The first entry is 1, true, false. The second entry is 1. And so at the end, we're going to get a length 8 row vector with all zeros and ones in it. Okay, you should think of that as all trues and falses in it. And so what should we expect when we type in u equals 1? Okay, well, u to the I times 1 over u to the I, or sorry, pi to the I times 1 over pi to the I, that should definitely be 1. So when I am asking, does this equal 1? Should say true for all of them. So let's check it out. And now I'm not going to put a semicolon. So what do I get? I do get a true-false vector because I use this equals sign. But I get true, 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 false, true, 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 false. So what does that mean? And this is why this video is called Matlab Mystery. It should definitely not be 1110, 1110. So for example, let's just think about what this 1 here means. This is asking if I do pi cubed, and then I do times pi to the negative 3, and then I ask, does that equal 1? Then it says true, it equals 1. What about the next one? Pi to the 4th times pi to the negative 4th. Okay, so pi to the 4th divided by pi to the 4th, does that equal 1? And it's saying false, it doesn't. And what's the reason behind this? The reason is that MATLAB, it does everything with a certain fixed amount of numerical precision, and so we should never expect a number like pi, do some arithmetic to it, to be exactly equal to some other number. The reason is that there is some certain fixed amount of rounding that is happening in MATLAB. It doesn't have infinite precision. Okay, computers never have infinite precision, and so some rounding happens. And what this 0 is indicating is that MATLAB, it thinks it sees a difference between this number here, which we secretly know mathematically is 1, and this number here, which it just has defined to be 1. And so what's the moral of this? The moral definitely isn't that we're going to have to go through and figure out what's special about pi to the 4th, what makes it different from pi to the 5th. The special thing is that you need to know that if you're doing some kind of arithmetic with real numbers, even with numbers like square root of 2 in MATLAB, you shouldn't expect anything to be exactly equal. So how could we fix this? What would be a solution? Well, a solution would be come up with some precision that you want, like maybe 8 decimal places is probably a good amount of precision. MATLAB's always going to be more accurate than 8 digits if we're doing standard operations like this. And so instead of asking, does this number pi to the 4th times pi to the negative 4th, does that exactly equal 1? Okay, instead, maybe I should ask, does pi to the 4th times pi to the negative 4th? Okay, let's look at that. Let's subtract 1. And maybe I want to ask, is that small? So a good way to ask, is that small? I can take the absolute value of this number and ask, is that less than 10 to the negative 8th? So what's 10 to the negative 8th? It's like 0.000 with 7 total zeros, then a 1. So it's asking, is this number here, pi to the 4th times pi to the negative 4th, is that really close to 1? Okay, and here I get true.